Hi everyone. Today we are talking about how to problem solve with your fractional equations. So what that means is we're going to talk about word problems. Let's start off with this first example, example 10 from your book. It says that Peter bought some shirts for $180. That was the total for all the shirts. If the price of each shirt has been reduced by $2, he could get 3 more shirts. Find the number of shirts Peter had bought. All right, go ahead and pause the video and try it on your own first. Okay, so if I'm trying to solve this problem and set up an equation, I'm actually going to use this hint that we don't know the number of shirts that Peter had bought. We actually don't know how much each shirt costs either. There's a lot of unknowns, but I'm going to use what is asked in the final question to set up my variable. We want to know the number of shirts that Peter had bought. So I'm going to set that as n. N is the number of shirts that Peter bought. Number of shirts bought. Okay, so then if Peter bought some shirts for $180, and we also don't know the price of each shirt, but we do know now that we have n as the number of shirts that Peter bought, then I can kind of think to myself, well, if I did know the number of shirts that Peter bought, I would take $180 and I would divide that by the number of shirts that Peter had bought to get the price of each shirt, right? So if for example, Peter bought 10 shirts, I would take 180 divided by 10, and then I would see that it's $18 for each shirt. Okay. But I don't have that amount, so I'm just going to think about the mathematical process that I would use if I did, and that would be division. Okay, so this right here tells me how much each shirt costs. The shirt cost. Okay, let me write that better. So by dividing, I would get the individual shirt cost. Okay, so that's like the normal situation. Now they're saying if the price of each shirt had been reduced by $2, he could get 3 more shirts. Okay, so this is the original shirt cost. They're saying if we reduce, subtract $2, he could get 3 more shirts. Okay, so we're just talking about the shirt cost. This is the normal shirt cost. Subtract $2, we would get a new price for each shirt. Still $180 total. If we wanted to figure out the new price after he bought 3 more shirts, we would just take 180 and divide by 3 more shirts, right? Which would be a lower cost. Again, we don't know. Oops, I used X. Let me fix that. Again, we don't know how much each shirt actually cost. So we set up this kind of division here. Originally, each shirt would have cost whatever 180 divided by n would be. If it was cheaper by $2, subtract $2, then we would get a new price where you would still take $180 divided by now the amount of shirts that you could buy, which is 3 more shirts. So this is all talking about the shirt cost. The original shirt cost, the subtraction of the $2 cheaper, and then the new cost, which would be cheaper when you divide by whatever the amount of shirts he had plus 3. Okay, so now you have an equation. We have 180 divided by n minus 2 equals 180 divided by n plus 3. All right, so here is my equation. I have fractions in it, so I know that I can multiply the entire equation by my denominators. to get rid of them. So I'm going to multiply it by an n, and I'm also going to multiply it by an n plus 3. Okay, so at the end I would have 180 times n plus 3 for that first term, divided by n, minus 2 times also n times n plus 3. That's it. Doesn't have a denominator. Equals this last term, 180 times n plus 3 over n plus 3. And some stuff is going to cancel out, which is what we want. So at the end, we get 180 times n plus 3 minus 2. Let me go ahead and multiply that. 2n times n plus 3 equals 180n. Okay, so just like that, I got rid of my denominators. Okay, I'm going to go ahead and rewrite that up on the top so I have enough room to actually work and get the correct answer. So I'm going to rewrite it up on top, and I'm actually going to simplify some stuff while I do that. So this becomes 180 times n, so 180n, plus 180 times 3 would be 540, minus 2n times n is 2n squared. Negative 2n plus times positive 3 is negative 6n equals 180n. Okay, let me just double check that everything is good. 180n plus all my signs. Yep, okay. Okay, now that I'm here, let me go ahead and move some stuff to one side so I end up with just 0 on the other. I have some terms I can combine though. 180n minus 6n is 174n. This is minus 2n squared plus 540. So I'm just moving stuff around. Equals 180n. I can subtract 180n from both sides. So I end up with negative 2n squared minus 6n plus 540 equals 0. Ooh, I don't like these negatives, so let me just flip all my signs. I can do that. 2n squared becomes positive plus 6n. This one becomes minus. So if I flip the sign for my first term, I gotta flip all my signs for my other terms. Okay, so I end up with 2n squared plus 6n minus 540 equals 0. I'm going to rewrite that up on top so I have more room. And it looks like I can actually take out a GCF, a common factor, of 2. They're all evens. So if I take out 2, it becomes 2 times n squared plus 3n minus, this is 270, equals 0. Okay, and then I can start factoring. I'm looking for two factors that multiply to get to 270, and let's see, subtract to get to a positive 3. Okay, so let's start listing some factors for 270. I'm actually going to start higher because I don't want to mess around with 1 and 270. I know that's not going to get me to 3. So let me start with, let's see, 270 divided by 10. We'll start off with that. It would be 10 and 27, right? So 10 and 27. That's not going to subtract to get me to 3. That'll only get me to 17. So let's go with Just going to go down the line. 12. No, that's not divisible. 270 divided by 14. No. 270 divided by 15. Oh, 15 and 18. Okay. 15 and 18. Okay, 18 minus 15 does get me to 3. So let's have 18 be positive and 15 be negative. Okay. So if I were to rewrite this, this would be 2 times n plus 18 times n minus 15. And then, yep, that works out. Set that equal to 0. I need to then set each of my binomials equal to 0. And then the answers are going to be the opposite signs, right? Because negative 18 plus 18 will get me to 0. And then positive 15 minus 15 will get me to 0. So I end up with negative 18 or 15 as my answer. And we're talking about the number of shirts that Peter had bought. Can't be negative, so we're not going to look at that answer. It's going to be 15 shirts. Now, if you are unsure whether that's the correct answer, you can always plug that back into the equation or the problem to see if it made sense. So let's see if it makes sense. Peter bought some shirts for $180. Okay, so 180 divided by 15 shirts. That means each shirt is $12. Okay, let's put that on top, $12 each. If the price of each shirt had been reduced by 2, so now it's $10 each, then he could get 3 more shirts. Okay, 3 more shirts would be 18 shirts. 18 times 10, yeah, does get us to $180, which is $2 cheaper. Yep, so it all checks out. 15 shirts. Okay, let's do one more problem from the book. Example 11. It says that the distance between 2 towns, A and B, is 120 kilometers. Simon drove from A to B, the 2 towns, at an average speed of v kilometers per hour. That's the speed. We don't know it. It's the variable v. On his return journey, his average speed was 10 kilometers per hour greater than his average speed from A to B. And hence, the time taken was 24 minutes less because he went faster. Find the value of v. V is that speed that we don't know. Okay, so you can go ahead and pause the video if you would like to try it on your own first. I drew myself just A to B. Okay, this is 120 kilometers, just so I can visualize it. This is the distance. Okay, I know I'm creating another variable, but stay with me, it'll make sense. There is the famous formula distance equals rate times time. That we're going to follow. The reason why this works is because let's say you had distance as miles. Rate would be the speed, miles per hour. Let's put it that way. Times time, time would be hour, measured in hours. So then those would cancel and then miles equals miles. So distance equals rate times time is a formula that you should remember because it makes logical sense that when you have the distance, it's going to equal to whatever your speed, your rate, miles per hour, for instance, multiplied by your time would be hours, for instance, because you're going to travel as far as however your speed is times your hours or your time. That's going to work out to tell you the total distance that you traveled by taking how fast you go and multiplying by how long you traveled for. Okay, so distance equals rate times time is something that if you don't have committed to memory, you should write down in your notebook because you will use that in problems that involve distance, speed, and time in both math classes and science classes. All right, I'm going to be honest with you. When I first saw this problem, I was like, I don't even know where to start. But it looks like when you read the problem, the interesting bit in this problem is that they're actually, like, the overall arching picture is that they're comparing the journey where Simon drives from A to B and comparing it to his journey back from B back to A, and talking about how the time he took was 24 minutes less on the return trip because he was going at a faster speed. Okay, so we are comparing the time it took. That's the overarching picture going on here, comparing the time. Okay, because I know there's distance and there's speed and there's time, so you're like, how do I come up with an equation? But this right here is the important part. We're comparing how the time was different. So let's take a look at this formula then. If we are talking about time, this formula is giving us distance, right? Distance equals rate times time. We need to get t, time, by itself. So if r is being multiplied by t, I can go ahead and divide both sides by r. I know you're probably thinking to yourself, what? This is all variables. How do I solve an algebraic equation with just, variables? Well, you can still do that. We're just moving stuff around. It's multiplication between the r and the t, the rate and the time. We're just going to divide both sides by r. R divided by r cancels. So we get t equals d divided by r. Okay, so we're looking at this formula now. Time is equal to distance divided by the rate. So to figure out how long it took me to get somewhere, I need to take the distance, divide by my speed to figure that out. Okay, so we're going to use distance divided by our speed, our rate. The distance is 120 kilometers. Because whether Simon drove quickly or slowly from A to B or B to A, that distance is still going to be 120 kilometers. You can't change that. So on the way from A to B, the average speed is v kilometers per hour. That's the rate. Okay, so the distance is 120 kilometers divided by our speed, our rate, which was v. Okay, that's going from A to B. Okay, on his return journey from B back to A, his average speed was 10 kilometers per hour. That's our rate, okay? The first rate was V, we have no clue. The second rate was 10 kilometers per hour greater than his average speed from A to B. All right, so from A to B, again, the distance was 120 kilometers divided by our rate. They said was 10 kilometers per hour greater than this speed. Okay, so V plus 10, going faster. Now here's where they say the time it took was 24 minutes less. Okay, so the original journey was taking 24 minutes longer. This one was a longer time. So it would make sense that if I subtract them, I would get that 24. Their difference is 24 minutes. Now it's minutes. Everywhere else in this problem, they said hours. So we do have to take those minutes and change them into hours by dividing by 60. It's only a fraction of an hour. 24 minutes is only part of an hour. So we'll have to take that and divide by 60. So many fractions in this equation, right? We took the journey to B by taking the distance divided by its rate, subtracted the time from B back to A by taking the same distance divided by our speed plus 10, because it is faster now by 10 kilometers per hour. We subtracted them because one was faster than the other by 24 minutes, divided by 60 because one's in minutes, so we got to change them all to fit hours so that they're matching. Or else it'll look like it took 24 hours faster, when in reality it was 24 minutes. Okay? So I'm actually going to now rewrite this equation up on top so I have some room. 120 divided by V minus 120 divided by V plus 10 equals 24 over 60. Okay? And remember, our goal now that we have our equation is to get rid of our denominators so that we have it as just a normal equation that we would work with. Okay, so I'll get a different color then. And we're going to go ahead, in order to get rid of the V plus 10, the 60, let's just go ahead and multiply by each of those. Multiply by 60, multiply by V plus 10. Because later on, stuff is going to cancel out. So we start with the 120. 120 is going to be multiplied by each of those. And they're all going to be on top because those are not fractions. Minus 120, same thing, multiplied by the same factors, except the denominator is V plus 10, equals 24 times V times 60. Let me get more room. Getting a little cramped. 24 times 60 times V plus 10 divided by 60. Okay, so stuff is going to cancel. These V's cancel, V plus 10s cancel, and these 60s cancel. So at the end, I get 120 times 60 times V plus 10 minus 120 times 60 times just a V equals 24 times V, 24V, times V plus 10. So I got rid of all my denominators. Let me go ahead and simplify this equation so that I can start solving it. 120 times 60, put that in my calculator, is 7,200. Okay, times V plus 10, I'll deal with that later, minus the 7,200 again, times V, so just minus 7,200V, equals, these can be distributed, so this is 24V squared plus 240V. Now you're probably thinking to yourself, oh my gosh, these numbers are huge. Yeah, they're huge, but maybe later on we can take out a GCF, okay? So since we're multiplying the same numbers again and again, I have complete faith that we can eliminate and take out a GCF later. 7,200 times V is 7,200V plus 72,000 now. We're adding another 0 minus 7,200V equals 24V squared plus 240V. Okay, let me clear up some space. Okay, that way we can do our work with tons of space. So it looks like I'm going to have to move some stuff around and combine like terms. All right, so this is what it looks like, all cleared off. Let's go ahead then and see what we can simplify. Oh, I have a 7,200V minus a 7,200V, so we can get rid of that. And then let me just subtract 72,000 from both sides. So then I'll have my 0 equals 24V squared plus 240V. Let me move that over so I have more room. 0 equals 24V squared plus 240v minus 772,000. Okay, let's see if we can get rid of a GCF of 24. Does 72,000, can 72,000 be divisible by 24? Yes, 3,000. Okay, so I end up with 0 equals 24 times v squared plus 10v minus 3,000. Ugh, I still don't like that 3,000, but I don't have a coefficient that's greater than 1 in front of my first term, so that's good. I'm basically just looking for two numbers that would multiply to get to negative 3,000, but subtract essentially or add to get to 10. Let's see. Let's start with, I don't know, divide by 50 or something. Oh, hey! 50 times 60. Oh, yeah, that makes sense. So I end up with v. Let's see, the 60 would have to be positive so that it can subtract my 50 to get to that positive 10. So that means my v would be equal to 50. So 50 minus 50 would get to 0. Or I can consider negative 60, because negative 60 plus 60 will get to 0. However, we're talking about speed, so we're going to have to reject that negative 60 as a possibility, and we're going to go with 50, what is this, miles per hour, which is a very respectable, oh wait, kilometers per hour. It's a reasonable speed. It's not too ridiculous. It makes sense. 50 kilometers per hour.